In this video, we'll tell you about the open source tools we use, what we use them for, and why it matters that they're open source. Hi. At XView Solutions, we build and support virtualized computing environments. Our special focus is on virtualization for vintage, legacy, and end-of-life applications and systems. But virtualized computing can also make sense whenever simplicity, portability, cost, and timely results matter. The world of virtualized computing includes many different technologies. Most of them are proprietary, locking you into a particular vendor, product, or framework. So you may end up in the Hotel California, where even if you want to check out, you can never leave. But we take a different approach. We use open source tools and technology in the solutions, services, and support we provide. Why? Because the tools are free, with no restrictions or license fees. Anyone with enough tech savvy and skill can use them to build and support virtualized computing environments, just like we do. For our customers, that means freedom, flexibility, unlimited choice, and absolutely no vendor lock-in. Let me describe the foundations of our virtualization technology and how we use free software tools to build and maintain them. Our core infrastructure is built on industry standard servers, which we configure as host nodes. A host node can be located anywhere, on your premises, in a data center, or at a public hosting site. That means real flexibility and huge cost savings over cloud providers like AWS, Azure, and Google. We create virtualized computing environments by partitioning a host node into portable private operating domains, or pods. Each pod is an independent computing environment with its own processing, storage, and network resources, and its own Linux operating system. A pod is 100% software that completely mimics a physical computer, but it can be readily moved between host nodes or even devirtualized back into a real physical server. Workloads, whether single applications or entire computer systems, may be deployed directly within a pod or further isolated in containers like Docker or Podman, and in virtual machines like KVM and QEMU. Containers run Linux workloads. Virtual machines run workloads that need specialized or obsolete operating environments or different computer hardware. Migrating workloads to pods, containers, and virtual machines makes them independent of physical hardware. To create a host node, we install an RPM-based distribution like Alma, CentOS, or Rocky Linux on a commodity x86 server using the Anaconda installer with a customized Kickstart file. The target server can be located anywhere. To convert the server into a host node, we only need internet access. The installation itself is fully automatic. After the base installation is complete, we install some OpenVZ tools. With those tools, along with some scripts for automation, we can set up and manage portable private operating domains on the host node. We can also move pods between host nodes. Each pod has its own Linux operating system, which may be different from the operating system of the host node where the pod resides at any particular time. The pod is a complete and fully portable computing environment which supports traditional workloads, containers, and virtual machines. And it's reachable from anywhere, worldwide, with its own secure internet connection. Within the pod, containers may be managed by Docker, Podman, or other freely available tools. Also within the pod, virtual machines are supported with KVM and QEMU, including virtual machines for hardware architectures different from the host node. Additional public IP addresses may be assigned to containers and virtual machines to give them their own individual internet connections separate from the pod. For storage and backup, we use S3 Backer and Borg Backup in both host nodes and pods. S3 Backer can create and manage file systems of unlimited size using any cloud storage provider that supports the Amazon S3 storage protocol, and there are dozens of those providers. S3 Backer offers a secure and economical way to use cloud storage, just like a local hard drive. Borg Backup is archiving software that makes snapshot backups of data and can retrieve the saved data from specific points in time. Borg Backup features built-in compression and deduplication, which makes it possible to take fast and frequent backups. Using Borg Backup in conjunction with S3 Backer enables secure backup and recovery of entire pods and of datasets within pods. Because the tools we use are free and open source, so are the solutions that we build and support. They never go end of life, there are no forced upgrades, and there's no vendor lock-in, which means our customers have the freedom to manage their technology investment on their own terms and timeline. In upcoming videos, we'll talk more about the tools we use, how we use them to build useful technology solutions, and how you can use them too. So please check back soon. If you want to find out more about the free and open source tools we talked about in this video, click on the link below. Thanks for watching.